This next conversion that we're going to do is to convert from mass to moles. So let's keep sticking with the example that we've been using. Let's say that we have 54.06 grams of H2O, and we want to know how many molecules would be in H2O. So there are two conversion factors that we've been using here. One of them is our molar mass, 18.02 grams equals 1 mole. What do we also know about moles? We know that there are a certain amount of molecules per every mole of a substance. So I also know there are 6.02 times 10 to the 23rd molecules for every 1 mole. These are two conversion factors that we can use to convert the grams of H2O into molecules. So we can think of this as a two-step dimensional analysis here, because I'm multiplying by two fractions. Ideally, when we start getting into more complex dimensional analysis, you want to create just a line of fractions, essentially. So if I have 54.06 grams, first, and this is kind of the hard part, I can't jump straight from grams to molecules, right? I have to find the connecting step. This is where the problem-solving part of conversion factors and dimensional analysis comes in. This is the part that's not really clear, and you have to figure it out based on the given information, based on what you know, and based on what you're trying to figure out. I have grams here. I want to figure out molecules, but there's no one step that says, oh, there's this many grams for this many molecules. There are smaller steps in between, though. So if I convert into moles, like I did before, my grams cancel, right? Let's put the second step in there. So now I'm going to use this conversion factor, 1 mole over 6.02 times 10 to the 23rd molecules. Now I have a second step that connects with the first step. My moles will cancel here, and now I should have my answer. So when you do dimensional analysis, you might find, if you look online, other ways to do it, other visuals. There's the fence method, where you basically, instead of multiplying and showing the fractions, you create this little fence. It doesn't matter what direction you choose. I usually don't use the fence, but you can if you want to. What's nice about the fence is that it lays it out really clear for you, because eventually you're going to get these long chains of dimensional analysis where you're starting with one unit and you're taking step by step and step to convert. When you put this in your calculator, when you have a long thing like this, this is what I would recommend. So I'm going to erase this now. When you put this in your calculator, start with a parentheses, 54.06, multiplied whatever this number is. I'll just put a 1 there for now. Multiplied by, the thing about scientific notation, you should really always put scientific notation in another set of parentheses. And remember, you can put that little e in there for times 10, 23. So this is my whole numerator, okay? Then divide, so you remember you want to end your parentheses, divide, and then put everything in parentheses in your denominator. Because this is essentially a giant fraction, right? All of this divided, all of the numerator divided by all of the denominator. So you can put it in your calculator all at once if you want. If you want to do smaller steps with your calculator, totally fine. Do whatever you want. But I'm showing this to you, and it's important that you put all of this in your calculator correctly. So I'm going to go ahead and do that right now. I don't know if you can see my calculator there. 54.06. Times 1 times 6.02 e to the 23 divided by 18.02 times 1. Now I know you guys know you multiply by 1, it's the same thing. I'm showing to you right now just for an example. Hopefully you can see that. I think it's a little hard for you to see it. Either way, that's how you put it in the calculator. You type in your note, you press enter. Right here, I got 1.806 e to the 24. So that would be I'm just gonna go ahead and round, 1.8 times 10 to the 24th. What are the units? Molecules.